Okay, we're going to determine the number of solutions for each system of linear equations. To do this, I would first examine the slopes. Remember our slope-intercept form, y equals mx plus b? The value that's with the x is our slope. So let's take a look here. Our first example, we have a positive 5 and a negative 5 for the slopes, and the intercepts are different. So the slopes are different and the intercepts are different. When the slopes are different and the intercepts are different, that will give us one solution. So just a reminder, different slopes. The positive and negative lines would eventually cross into one intersecting point. Okay, number 2, it looks different, but if I examine that closely, there's also something that looks similar about them. For instance, if I doubled 3 times 2 would give me 6. If I doubled y, it would give me 2y, and if I doubled 4, it would give me 8. So if I times everything in this equation by 2, I could actually get a twin. Or in reverse, if I cut everything in half, half of 6 would give me 3, half of 2 would give me y or 1y, and half of 8 would give me 4. So at first I thought that they were different, but when I look at them closely, I do see that every value is exactly the same. And if things are exactly the same, we said twinfinite solutions, like twins are the same, or infinitely many solutions. If we put these equations into slope-intercept form, they would make the exact same line. And then your last equation, let's see, slopes are identical, same slopes, but different intercepts. So that means they, on a graph, if we had a graph, they would be at different intercepts. So like -8 would be down here, or -1 would be down here, and +2 would be here. But they would rise and run at the same rate. So like down 1, forward 3. So they would kind of go in the same place. So same slope, but different intercepts create parallel lines. Parallel lines never cross. So that would be no solution. Okay, now we're going to graph these, the system. We're going to graph each line and we're going to see what happens. Okay, remember again, y equals mx plus b. Begin at the b and put a point. So for number 1, we're going to begin at -2 and put a point. And then we look to our slope to see how we rise and run. Now this one, there's nothing in front of the x. That's an invisible 1. Remember that slope is rise over run. So we will rise 1 and run 1 from that point. And then I will repeat that. Rise 1, run 1, rise 1, run 1, and so on. I'm going to fill up the graph for the first equation. Then neatly connect. Okay. The next equation, again, y equals mx plus b, begin at the b and put a point. So I'm going to begin at +4 and put a point. And again, my slope is rise over run, and it's the number in front of the x. Slope is right there in front of the x. So we have a -2 for our slope. I'm going to say the run is 1 because -2 is a whole number. So I'm going to go down 2, forward 1, down 2, forward 1, that's where it hits, down 2, forward 1, and then neatly connect. Okay, and then this line should be going down, decreasing because it's a negative slope. Okay, then X marks the spot for our solution. Our solution is an ordered pair. It's the x value and the y value. So this one is on the x, it's at 2, and on the y, it's at 0. So 2, 0 for my ordered pair. Okay, same thing's going on here, but my first analysis of these equations is I notice that these have the exact same slopes but different intercepts. If they have the same slopes, they're going to be parallel. But let's go ahead and put them on the graph. Y equals mx plus b. Begin at the b. So I'm going to begin at positive 1 for my first equation and put a point. And now my slope is the whole number 2. Remember, slope is rise over run. And if my slope is 2, the whole number 2, the run is 1. Okay, so from there, I'm going to rise. From positive 1, I'm going to rise 2, run 1. Rise 2, run 1. I'm going to reverse this and drop 2, back 1, drop 2, back 1. And then go ahead and connect all the way through the graphs with arrows at the end. Okay, so that's my first line. That's done. Now for my second equation, I begin at the b, the intercept, which is negative 2. And this one is the same slope. Rise 2, run 1. Rise 2, run 1. And you can see they have different intercepts, but because they have the same slope, it forms parallel lines, and parallel lines will never cross. So no solution. Okay, next up, let's keep in mind our y equals mx plus b. Begin at the b and put a point. So we begin at negative 4. And my slope is a whole number. It's 3, but remember, slope is rise over run. So from negative 4, I'm going to rise 3 and run 1. Repeat that. Rise 3, run 1, rise 3, run 1. Connect. Okay, that line's done. Now be careful on the next one. We're going to begin at positive 3, but the slope is negative, so this line should decrease or go down. So instead of rising 1, I'm going to go down 1, but then forward 2, down 1, forward 2. Okay, X marks the spot. What is my solution? Where do they cross? They cross at 2, 2. Now we're going to write a system of equations in slope-intercept form. So that means we're writing them into y equals mx plus b. And we're going to model the cost of a truck rental company. So Kyle is renting a 15-foot moving truck to move into his new home. The first truck charges a fee of $30 plus 75 cents per mile. So they're going to charge that fee up front. That's our B, that's our initial value. And then they're going to also charge 75% per mile. That's our slope, which is also the rate that they're going to charge. So my formula looks like this. The initial fee, that $30 charge, is the intercept, and the per mile is the rate or the slope. Okay, let's do it for the next company. The next company charges a fee of $29 plus 80 cents per mile. So similar to the other truck company, our rate is 80 cents per mile, so that goes here. That's our slope or our rate that they charge. And then the initial fee, the B, the startup fee, is $29. Okay, next we're going to graph the two equations. A zoo had two cubs, that were born December 31st. One weighed 3 pounds and the other weighed 2 pounds. The first cub was gaining 6 pounds per week, and the other cub was gaining 7 pounds per week. At which week did the cubs weigh the same? Okay, so we're going to put our weeks down here, and we'll put how much they weigh, their weight up here. And it looks like I could maybe go by ones on the graph. 1, 2, 3, 4. I'm not sure how to scale the other side, so I made a few tables. I'm going to input some weeks to see like where we're headed here. So if I do 6 times 1 week plus 3, that's going to give me 9. If I do 6 times 2 weeks plus 3, 12, 13, 14, that gives me 15. And if I do 6 times 3 weeks plus 3, that's 18, 19, 20, 21. And then I'm going to go over here and do the other equations. 7 times 1 week plus 3, that's 7, or plus 2, sorry, plus 2. That's 7, 8, 9. Ooh, that's a common point. 7 times 2 weeks plus 2, that's 14, 15, 16. And 7 times 3 weeks plus 2, that's 21, 22, 23. Okay, so I'm going to get up to 23. Let me count and see if we can just go by ones. Or actually, I see that these values here are like going by threes. I'm going to skip count by 3. So I'm going to go 3, 6, 9, 12, 15, 18, 21. Okay, so now I'm going to go ahead and graph my equation or my ordered pairs, but I already see that that's going to be the answer right there. Okay, so now I could either just graph the equations or graph my ordered pairs. I'm going to go ahead and graph my ordered pairs. So over 1 up 9, over 2 up 15, over 3 up to 21. Okay, there's one line. Begins at 3. Okay. And then the second line, so I did this line in yellow. I'm going to do this line in green. Over 1 up 9. Over 2 up 16. And over 3 up to 23. This is tight. Begins at 2. Okay. So it almost seemed like they were going to be similar or almost the same line, but the slopes are different. So I know because they have different slopes that they will eventually cross. And at week 1, the cub weighed 9 pounds. So that's when they both weighed the same right away after week 1. Okay, now we're going to just substitute our x values into our equation to get our y values and see if we have any common points. Also, your teacher should have told you that there was one little typo here, that this should be -4 right here. Okay, so let's go ahead and substitute in. So -3 times x, which is -2 minus 3. A negative times a negative is a positive. And 3 times 2 is 6. 6 minus 3 is 3. Okay, then I do my second point. -3, I'm substituting in -1. A negative times a negative is a positive. 3 times 1 is 3. And 3 minus 3 is 0. Okay, now I'm going to substitute in the 0. -3 times 0 is 0. And 0 minus 3 is -3. And sub in the 1. -3 times 1 is -3. And -3 minus 3 is -6. And I can see a pattern here that it's just decreasing by 3 each time. Okay, then moving on to the second equation. I'm going to go -4, remember this was a -4, times -2 minus 4. Okay, a negative times a negative is a positive, so that becomes 8 minus 4, which is 4. Okay, and then I'm going to go -4 times -1 minus 4. A negative times a negative is a positive, so that's 4 minus 4, which is 0. And now I'm going to sub in the 0. I'm a little cramped for space over here. I'll put it right here. So -4 times 0 minus 4. 4 times 0 is 0. 0 minus 4 is -4. I can see this is decreasing by 4s if I continue the pattern. And I also see that we have a common point. We have a solution. So the solution is -1, 0. Name the number of solutions. Okay, so to look at this, remember our slope-intercept form, y equals mx plus b. I would first check out the slopes. And look at here, these have the same slope, but the intercepts are different. If they have the same slopes but different intercepts, they would be parallel lines, and parallel lines would never cross, so this would be no solutions. No solution. Okay, examining the next set, I'm looking at the slope, -8 and +8. The slopes are different, but the intercepts are the same. But the slopes are different. I'm going back to that. When the slopes are different, they would eventually cross. So this would be one solution. They would intersect. Think about it. The first line is a negative slope, so that would be decreasing or going down on a graph. And the second line is a positive slope, so eventually they would cross. And the last one has different slopes and different intercepts. And again, just like I said on the previous example, if the slopes are different, they will eventually cross. So one solution.